So good morning and welcome to Thermodynamics lecture number 12. Well, just to have a recap, what were we doing in the last class? What we had discussed in the last class? What was the topic of discussion?
Parallel connection.
Okay, we were dealing with conduction and we were dealing with series and parallel connection. Today is the day when we try to solve some problems and see how we can utilize those things that we have learned in the previous class. But before going into that, I will just tell me one thing. I sent you the sheets. Have you got those sheets with you now?
Yes, sir.
Okay, that's good that you have got those sheets. So what I'll do is I'll just tell you what all things you need to go through in those sheets. So you can just note it down. I'll just go through them quickly because this is my job to let you know that what all things you should know. We have already covered those things, not a problem. uh, Difference between conduction, convection and radiation, I think we have covered most of this. Heat flows from hot end to the cold end. To the cold end, particles do not leave their place. In convection, they actually leave their place. In radiation, we have not studied radiation, but if I give you a brief review about radiation, in radiation, we do not need any medium. So there is no possibility of any motion or no motion. It does not need any medium. If there is no medium, there are no particles. There are no particles. It doesn't matter whether there is motion or not. So it is basically the traveling of electromagnetic waves. We will deal with radiation in great detail. Medium is necessary, medium is necessary, medium is not necessary. It's a slow process. We have already seen that it takes time for the rod to become hot from one end to the other end. It's a slow process because because heat is getting transferred because of collision. It will take some time. Similarly, convection is a slow process, but radiation is a very fast process. You radiate, patak karke, the heat, the radiation travels, and radiation travels with how much speed? It's saying that it's a fast process. How fast it does fast process? For example, this is radiating heat. Now this radiation is traveling, whether it is vacuum or whether it is any medium, it travels. How fast does it travel? With what speed does it travel? Radiation itself is a fast process. Radiation refers to the process by which this heat energy is emitted. Radiation also refers to the process by which this heat is transmitted. Radiation also refers to the heat itself. So radiation, when we use the term radiation, is a multi-meaning term. How fast does the radiation travel? Do you know this? Yes or no?
No, sir.
It's electromagnetic wave, so it travels with the speed of light. You must know this. It travels with the
3
speed of
into 10
light.
to 3 into 10 to the
Yes,
power.
it travels with the speed of light. Path of heat may be zigzag. If the rod is in a different shape, the path may be zigzag. The path may be zigzag or curved. Path is a straight line because electromagnetic wave they travel in straight lines. Conduction is a basic heavy mode of heat transfer in solids. This is in fluids, anything that can flow. It can take place in any media. It does not require media, so it is for all media. The temperature of the medium increases. If you can see from hotter end to the colder end, I told you when it is steady state, the different section will come to different temperatures. Those temperatures will be different from each other, but will remain constant. So the medium is getting heated up. In convection also, the intervening medium is getting heated up, but in radiation, no medium is getting heated up. Do we understand all these points? Yes or no?
Yes, sir.
Keep all these points in your mind because in JEE, it's not all about solving questions, especially in multiple choice, which we'll do one or two in this class. It's all about whether you understand the concept or not. And that is why all these theory questions are equally important. We have already done the definition of conduction, so I will just not go into it. We have already done that. Do we remember it? Yes or no?
Yes, sir.
Okay, we have also seen what is variable state and a steady state. In variable state, the temperature of different sections, they will be different, but they keep on changing with time. But in steady state, these different temperatures will remain constant with time and the temperature gradient becomes constant. Do we remember this?
Yes, sir.
Now, this is how the graph looks like. This is how the graph looks like. Is this a graph of temperature of variable state or is it a graph of steady state? Tell me.
Variable state.
Because for a steady state, the temperature gradient must be
Equal or same. Constant.
constant, right? So, this is how questions are framed, and that is how you must understand how to do this. Then there is a concept known as isothermal surface. You might not have heard about it, but this isothermal surface, if I do this isothermal surface, I am doing three things at the same time. Isothermal surface. Isothermal surface means a surface
Temperature constant.
at which the temperature remains constant. Now, the second thing which has the same meaning, similar concept, instead of calling it isothermal surface, I can call it
Isobaric surface.
equipotential surface. Do we understand this? Equipotential surface. Equipotential surface. Do we understand the difference or the similarity between the two? Yes or no?
No, sir.
Why no, sir? Thermal current and electric current are similar concept. Yes or no?
No, sir.
No? They are not similar concepts. Then I'm very sorry what we have learned in the last class. You don't remember anything from the last class?
I am not in the last class, sir.
Yes, beta?
I was absent, sir, from last week.
You were absent from last week. Oh, that's very sad. And remember, if you are absent, it's not my fault. You might have some important work. You might have some personal tragedy. I can understand that. But even if this ceiling right above my head, if it falls down, even then I should not miss a class. Even if I am on my deathbed right now, I should not miss the class. Even on my deathbed, I must be watching the lecture, because if I live the next day, I must be prepared for the lecture for the next day. Do you understand this?
Yes, sir.
And if I commit the crime, murder, cold-blooded murder of missing the class, if I do that, if the ceiling actually falls on my head, and I just can't come to the class, and I just don't have a TV where I can watch the lecture, then before coming to the class, and for the next class, I take some time out of my busy schedule and watch the previous lecture, because you have the facility to watch the previous lecture. Yes or no? Yes or no? Do we have the facility?
Yes, sir.
So we should do that. There are 1,000 excuses in this universe, beta, of not doing something. There is only one reason to do it.
Corona आया था, sir, positive.
I'm not exaggerating it. See, beta, if you come to the class before doing the last class, it's a waste of time. Don't waste your time. Do something else in that time. If you come to the class, you must be prepared. You must know what has happened in the previous class. Else, it's a waste of your time, beta. You can't waste time. That is one thing that you cannot earn back. You can earn back money. Even you can earn back your respect if you lose it at some point in time, but you cannot earn back time. Remember that. So thermal current flows because of difference in temperature. You've seen that. Please check the lecture. Electric current flows because of difference in
Potential difference.
And therefore, isothermal surface is equivalent to equipotential surface. Do we understand it now, bacha?
Yes, sir.
So this is the second concept that is similar to this. There is one more thing which is exactly similar to this, and these three come from three different topics of physics, which are all there in your course in different ways. Isothermal surface, surface with same temperature. Equipotential surface, surface with same potential. What is the third brother? Brother from another mother. Brother from another chapter, I should call it. Who is the third brother of these gentlemen? And they all three are similar things. If you understand one, we should be able to understand the other two brothers. Cousins, you can call them. The third one. You might not have an idea about third one, so I'll not expect that you will not. The third one is wavefront. Now, wavefront is also a very similar concept. What is wavefront? Do you remember wavefront? Spherical wavefronts, cylindrical wavefronts, plane wavefronts. Do you remember anything about wavefronts? Anyone? No? Either you remember it, yes, it's a binary question. It's a binary answer, 0 or 1. No or yes. Do you remember it?
0.
0. You don't. Wavefront is the locus of all points which are in the same phase. Do we remember it now? It comes from the topic known as wave optics. Do we remember it now? Wavefront. Spherical wavefronts, cylindrical wavefronts.
I forgot it, sir.
कोई बात नहीं. Wavefront. Now these three are similar topics. Now, if I look at equipotential surface, equipotential surface, electric field lines are perpendicular to the equipotential surface. Yes or no?
Yes.
And if electric field lines are perpendicular, current will also be perpendicular because current flows in the direction of electric field. Yes or no? Is the flow of positive charges flow in the direction of electric field? Yes or no?
Yes, sir.
See, this is a planar isothermal surface, and look at the direction of electric current. Is it perpendicular or not?
Yes.
So electric current is same as thermal current. Equipotential surface is same as isothermal surface. Do we understand this? Do you understand this now?
Yes, sir. Yes.
Now, about wavefronts. If a wave is traveling, dung, 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 and if the waves are straight lines, yes or no? Now these are rays or rays traveling, rays of light traveling. I can always draw. What? My face? No, not my face. I can always draw a surface. If I see any point on that surface, they all will be in the same phase. Yes or no?
Yes, sir.
This will be a wavefront. And then we have Hygen's principle of wavefront, from where we can find out the position of the next wavefront. Do we understand this now?
Yes, sir.
Now, who creates planar wavefronts, or who creates planar isothermal surface, or who creates planar equipotential surface? A source of light, which is very, very far away. The wavefront it will create will be planar. Do we remember it? Yes or no?
Yes, sir.
Electric field lines, if they are parallel, they will create equipotential surface which are planar. Yes or no?
Yes, sir.
Everything is same. All these three concepts are same. Who creates spherical equipotential surface, or spherical isothermal surface, or spherical wavefronts? Who will create a spherical wavefront? Any point source of light or any spherical source of light. Do we understand this?
Sir.
If it is a point charge, it creates spherical equipotential surface. Do we understand this?
Sir.
If it is a point light source, it creates equipotential spherical wavefronts. Spherical wavefront, not equipotential. Spherical wavefront. Do we understand this?
Yes, yes.
Then we have cylindrical wavefronts or cylindrical isothermal surfaces or cylindrical equipotential surface. Who is going to create a cylindrical equipotential surface? All three are same. A line source. Do you remember line source? A line charge. If I have a line charge like this, dung, 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 what type of equipotential surface it will create? Electric field lines will go like this. Yes or no?
Sir.
You must remember Gauss law. You must have found out the electric field due to a infinite line charge, and there you had created a cylindrical Gaussian surface. Do we remember this? You just must have done it now. Yes or no?
Yes, sir.
So the moral of the story is all these three things are same. Am I clear? Yes or no?
Yes, sir.
Binary answer. Okay. Now we are already done. Temperature gradient. Don't tell me don't remember it. Temperature gradient is the difference in temperature or change in temperature divided by the distance. This temperature gradient is same as potential gradient. Change in potential divided by the distance. We get potential gradient and temperature gradient. We have already discussed this. Please go through this once again. If you have not done it, please watch the lecture again. Please go through these notes. Everything literally is there in this note. Then we had also done how do you find the heat current, delta Q by delta T or dQ by dt, or delta Q by delta T is Ka theta 1 minus theta 2 or theta 2 minus theta 1. We have already done that. Let us move forward. Let us not waste time here. Done this, done this, done this. Then what? Then we have done thermal resistance. Yes or no?
Sir.
Thermal resistance is L divided by Ka. We call it RTH. This K is known as coefficient of thermal conductivity. We have also seen what is the relation between coefficient of thermal conductivity, resistivity of the wire, the electric wire, and conductivity, electrical conductivity of the wire. Everything is similar. We are doing similar things. And in this one table, that similarity has been very nicely captured, and that is why this sheet is there with you. If I'm not there, this gentleman is my substitute, because everything that I tell you, not everything, it doesn't scold you, but yeah, everything else is there in this. Take electric conduction, electric charge or current flows from higher potential to lower potential. Remember, we're talking about the positive charge carriers, which is not the actual charge carriers. Heat flows from higher to lower. Electric current or thermal current is dq by dt. You can also write it in thermal current, and this relation between current and potential difference, the relation between current and heat current and temperature difference, and all these sort of things are there nicely illustrated in this table. Do we get this, or should I explain anything?
Yes, sir.
Clear?
Yes, sir.
Well done, my dear friends. Then comes my favorite, your favorite, everyone's favorite, questions. And I love questions. And let us see if I can get it here in the correct form. And this is the question coming right in front of your eyes. Remember, questions are not going to be straightforward. I might give you something else, but remember, you must have that faith that you know it and you should be able to do it. Two rods, one semicircular and another straight of the same material and the same cross-section area joined as shown in the figure. The points A and B are maintained at different temperatures. They have to be, otherwise there will be no flow of current. The ratio of the heat transfer to the section, semicircular section, to the straight rod wala section is in a given time. Waiting for your answers. I hope you understand the question.
Yes, sir.
Well, then the answer should be there, my dear friends.
Wait, sir.
Yes, yes, I'll wait. Don't worry. I have enough trust in your abilities, beta.
5:2.
And the answer is, I mean, which option? A, B, C.
C.
Think again. Think again. Is it correct? Is it not? ratio of semicircular to the straight one. Please remember this, bacha. I hope you are finding out the right ratio and not the wrong one.
Pi is to 2, sir.
Pi is to 2. Okay. I think so. That would be correct. Let us see how the solution is given. Basically, we have to find the ratio of heat transfer. So dq by dt, it is Ka into delta theta by L. Yes or no? Yes or no?
Yes, yes.
So now do we have the answer? This delta theta is same in both cases. Yes or no?
Yes, sir.
This K is same in both cases. Yes or no?
Yes.
This area is same in both cases. Yes or no? So then this comes yes or no?
Yes, sir. उल्टा लगा दिया.
हो गया बेटा, +4 की जगह -5. So you leave? No, you leave. You lose 5 marks, dear bacha. So you should not do a mistake like this, because remember, understand that the reverse answer will always be there. So this is the lesson that we gain from this, apart from the lesson that we should never miss a class. If you miss a class, I have really no sympathy. If you are alive, you must be in the class. If you are breathing, you must be in the class. There's no way that you cannot be in the class. Okay, there could be personal tragedies. There could be really very big personal tragedies. That's a different thing. Otherwise, you cannot miss this class. And the next one is here. IIT-JEE 1978. A room is maintained at 20 degrees Celsius by a heater of resistance 20 ohms and 200 volt mains. Okay. The temperature is uniform throughout the room and heat is transmitted through a glass window of area this, thickness this. What will be the temperature outside? Thermal conductivity of glass is falana and J is dhimaka. The question passes on to you.
Ka delta theta by L into T.
I see this is a objective question and you must give me the answer. 15.24 degrees Celsius, 15 degrees Celsius, 24.15, none of the above.
Sir, I'm doing, sir.
Yes, I do. Doers are the achievers. Those who do, they only achieve things in life. No one else achieves anything. I hope you understand this. This is IIT-JEE. IIT-JEE means previous times it was known as IIT-JEE. I also never gave JEE Main or JEE Advanced. I gave this one, IIT-JEE. Indian Institute of Technology Joint Entrance Examination. Those were the good old days, my dear friend. Yes, you were probably not born when I gave my exam. Okay.
24.15 degrees Celsius.
24.15 degrees Celsius is the wrong answer, my dear friend. Again, same mistake. Okay. Anyone with a different answer, or shall I move ahead and reveal the solution? It's a very simple one, my dear friends. Whatever heat this heater is generating.
Actually, yes, sir. Current electricity. Heat is equals to I.
That heat must be flowing out because the temperature remains constant. If that heat is not flowing out, the temperature of the room should rise. Yes or no? Do we understand this?
Yes, sir. Yes.
That's it. That's it. So this whatever heat this gentleman is generating that must be flowing out, and that is the basic concept. And then the temperature of the room constant, the rate of heat generated from the heater should be equal to the heat flown through the glass window. Heat generated is V square by R. In time t, this much heat will go out. Yes or no?
Yes, sir.
V
Yes.
square by RT. This is divided by joules. Why? Because we want to convert it into calories. Because the other side we have calorie wale terms. Do you understand this? K is given in per calorie. So either we convert that K into joules or we convert this joules into calories. Do we understand this?
Sir, yes.
Yes, sir, yes, sir, yes, sir. Then K, sir, then A, sir, then delta theta by L, sir, then T, sir, then T, sir, T, sir. Goes away, sir. We get the value of this delta theta. This delta theta is nothing but 20 minus theta. From there, sir, we get the value of theta, and the value of theta comes out to be 15.24 degree Celsius. Bacha, thoda dimag use. If it is hotter outside, why will I burn heater in my home, beta? It should be colder outside, no? That's why I'm burning heater. Yes or no? So how come you say 25 degrees Celsius? It cannot be that way. Outer is warmer and I burn the heater to make it colder inside. Is it possible? It has to be colder outside, no, bacha? Yes or no?
Sir.
25 degree cannot be the answer. Even common sense will tell us that it cannot be the answer. Do we understand how we have done this, everyone? Can I have some reason that we understand this?
Understand, sir.
Pakka?
Pakka.
Chalo, let's see how pakka is your pakka. How pakka is your pakka? And this we have not done, so I will not do this. Okay. To begin the next set of questions, we will just go through the combination of conductors. We have already seen the combination of conductors, series combination, yes?
Yes, sir.
Hello, we remember this? Then we have also seen the what? Parallel combination, yes or no? Then I must bring this question into the picture. Oops, why this is happening? This should not happen. This is wrong. This is happening. This is wrong. Okay. Then comes this question, my dear friends. This is question number 10. Banaras Hindu University, 1998. There was once upon a time when BHU was not an IIT. For me, it is still not an IIT. It is BHU. IIT-BHU, it was known as Institute of Technology, Banaras Hindu University. Now one I has been added, so it becomes Indian Institute of Technology, Banaras Hindu University. This is the question from there. It used to have a separate exam, which I never gave. I did not consider it to be worthy enough for intelligent guy like me. Two rods of the same length and same material transfer a given amount of heat in 12 seconds when they are joined end to end. But when they are joined together, then they will transfer the same heat in same conditions in how much time? 24, 3, 1.5, 48.
Wait, sir. Doing.
Yes. I know that you are trying. Doers are achievers. Achievers are doers. Dreamers are not achievers. They are not doers. They don't do anything. They don't achieve anything. They only dream. You dream, but you wake up and then you work towards that dream. Waiting for your answers. Two rods, same length, same transfer. Same transfer, same material. End to end joined. 99. Heat is transferred in 12 seconds. See, it comes from whatever we have learned, but the question is not going to be straightforward. They will not tell you, okay, series mein kitna aega and parallel mein. How much?
3 seconds.
3 seconds is the answer that I have achieved. Let me see. I have not calculated it. Let me see the answer. And it is 3 seconds, my dear friends. Well done. So we are now getting to understand how it is done. It is a very simple question. In first case, they were put in series, yes or no. In the second case, they were put in parallel. So if I see the formula for heat current, K is a constant, T we have to find out. So I have cut it. Delta theta, change in difference, change in temperature is constant. So I can write that the time is directly proportional to L by A, because Q, the amount of heat, same amount of heat has to be transferred. So time is proportional to L by A. Do we understand this?
Yes, sir. T1 equal to L1 into A2.
Yes. Now we have smiles on our face and answers in front of our eyes. T1 by T2 becomes L1 by L2 into A2 by A1. Then we do dhang, 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 dhang. And after doing this dhang, 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 we have the answer as 3 seconds. Do we understand this? Can I have some reason that we understand this?
Yes, sir.
Then, my dear friends, we have a dream question coming up. Dream question comes from the exam, that is a dream exam, and here comes the dream question. IIT-JEE screening 2001. IIT-JEE has many patterns in the past. Some point in time, even during my time, just not in my year, it had a screening paper. It was just like main. So you clear that screening, then you prepare for the main JEE. IIT-JEE screening 2001. 3 rods made of the same material and having the same cross-section area have been joined as shown in the figure. Each rod is of the same length. The left and right end of the rod are maintained at 0 and 90 degrees Celsius. The temperature of the junction of the 3 rods will be how much? I'll tell you a very important, a very interesting story about this particular question. Obviously, this question came way back when I gave my IIT, but I'll tell you a story 5 years before this, maybe 6 years before this. 1995 was the year. I'll tell you this story because I had solved this problem, and this problem had given me some really interesting thoughts. The year was 1995. It was summer of 1995, not the summer of 69. Summer of 1995. I'll tell you the story of summer of 1995. Do you know how to solve this one? I knew it in the summer of 1995. Yeah? Na? Anyhow, any hopes of getting this one? I shall give you time. Just in the memory of the year 1995 and the summer of 1995. This is summer of 2022. Yes, 17 years.
60 degrees?
60 degrees. So is it a guess or is it... you remember, beta, we are not playing Kaun Banega Crorepati and you don't have lives. And you're not cat. I just said that a cat has 9 lives. You don't have. You have just one. You live once, you die once. I mean, it's a famous dialogue from a Shah Rukh Khan movie. हम एक बार जीते हैं, एक बार मरते हैं, शादी एक बार होती है, प्यार एक बार होता है, जेई 2 बार होती है. एक साल में 4 बार जेई मेंस, इस बार 2 बार होने वाला है. But for us, it's just one. We only live once, we only die once. We only attempt a question once in a JEE paper because we don't get time to attempt it again. So is 60 your correct answer? And you are not playing Kaun Banega Crorepati, right? You cannot guess. Guessing is not allowed in physics. Yes. How did he do it? That is the next question then. The answer is definitely 60 degrees. Congratulations. How did you get it? I did not know the answer. I'm just seeing the answer now. How did you get it, Bacha? Tell me.
Theta into K1 plus K2 equal to K1 into theta 1 equal to K2 into theta 2.
Tell me again. If I call this as rod 1, okay, if I call this as rod 2, if I call this as rod 3, are the resistance of these rods same or different?
3 are same.
All three are same. Okay, let me call the resistances R. Now, please go ahead. What do you wanted to tell me? Please go ahead.
So first one is series with the parallel. 2 and 3 are parallel.
Okay, good. Well done. Wow. If I could have changed the question, bacha, just to confuse you, if I, instead of making it as 90 degrees Celsius, if I would have made it as 100 degrees Celsius, then what would it be have been your answer? You are very correct. If they are 90 degrees, B and C are in parallel. That is absolutely bang on. But if it was 100 degrees Celsius, then does anything change? Are they now in parallel, bacha? B and C? Yes or no?
Parallel, sir.
They are still in parallel. B and C, if I make the other end as 100 degrees Celsius, the third end as 100 degrees Celsius, are they still in parallel?
Parallel, sir.
No, they are not in parallel.
Why, sir?
Why, sir? Beta, sir? Because this is 90 degrees, sir, and this is 100 degrees, sir. They must be between the same temperature difference. Yes or no? To be in parallel?
Yes, sir.
Are they having the same temperature difference now? So they can't be in parallel. Yes or no?
Yes, sir.
So you easily could have done the screening question. So let me just rub this one out first so that I don't confuse you. We'll do this question, don't worry. Right now they are in parallel. Yes, they are in parallel. That is correct. So if I call this gentleman as R, this gentleman also becomes R. Their effective resistance becomes R by 2. Yes or no?
Yes, sir.
And then it is in series with the first rod. Yes or no?
Yes, sir.
From there you can find out what is the temperature of the junction. Yes or no?
Theta into 3 are equal to 90 into 1 is 0 now, sir. 0 degree Celsius means it becomes 0 and plus 90 into 2, 90 into R. 90,
So
90.
basically, this is 0 degrees Celsius. You can call this as T, right?
Yes, sir.
So basically, what you want to see, I'll try to say this in a different way. Okay, I assume that the heat current is flowing like this. Now you will tell me, sir, this is the wrong direction. Doesn't matter. I know that this is the wrong direction. Don't worry. So let us say this is Q1. Do we understand this? Q1 or delta Q1 heat current is flowing like this. The direction is wrong. I know that. Don't worry about the direction. Delta Q1 heat is flowing like this. Yes or no?
Yes.
It is reaching this point. After this point, what will happen? Some heat current will go in this direction and some heat current will go in this direction. Yes or no?
Some,
Yes or no?
some of the entering current equal to outgoing current.
Yeah, sum of incoming is equal to sum of outgoing. Does it remind you of anything? Sum of incoming is equal to sum of outgoing. Does it remind you of anything? Yes or no?
Yes, sir.
What?
Kirchhoff law.
Junction law. Are we
Junction.
applying the same junction law here?
Yes, sir.
So things are same. Now, how much is the value of this delta Q1? Now, remember, when you are doing it by this concept of delta Q1, you don't have to do it by series or parallel. This could be anything. Even if it is not 90 degrees Celsius, even if it is 100 degrees Celsius, the concept remains same. Do we understand this?
Sir.
Because it is not looking at the series and parallel combination. Yes or no?
Yes, sir.
Okay. So the equation that I have, and I hope everyone agrees on this, is delta Q1 will be equal to, or I should say delta Q1 by delta T heat current will be equal to delta Q2 by delta T plus delta Q3 by delta T. Do we understand this? Yes or no?
Yes, sir.
That's it. I write the value of delta Q by delta T. How much is delta Q by delta T? Now remember, look at the direction that I've drawn. According to that direction, you tell me what is the value of delta Q1 by delta T?
So here,
Hmm?
theta into 3R.
No.
saying equations.
Delta Q, no. It is 0 minus T divided by R. Do we understand this?
Yes, sir. I'm saying also that one only, sir.
No, no, no. You're not saying that one, bacha. You said T divided by R. This minus T divided by R. Because look at the direction that I have drawn. I'm assuming that it is flowing like this. So this has to be higher and this has to be lower. This is my assumption. Do we understand this?
The 0 minus t is a delta theta, na, sir.
You just can't write delta theta. You have to write in terms of values now, bacha. Then only you will find out the value of T. Yes or no?
Yes, sir.
Now can you tell me what is delta Q2 by delta T? Remember I have drawn the direction. Remember the direction that I have drawn. Darang,
T minus
Padang
90.
and Sadang. Yes.
T minus 90.
T minus 90 divided by R. All the resistances are same. Yes or no?
Yes, sir.
Plus what?
T minus 90 by R.
Now does it make a difference whether the temperature was 90 or 100? If it was 100, what would have you returned? If this was 100, what you would have returned? T minus 100 divided by R. Yes or no?
Yes, sir. Same process.
Same, sir. Same, sir. We get the values from here. Do you understand this? The
Yes,
value
sir.
of T. And the value of T that comes will be equal to how much, my dear friends?
So 3t equal to 180. T equal to
3T is equal to 180. And
equal
my
to 60.
T would be equal to 60 degrees Celsius. The notes have solved this in a different way. You don't have to see. I can't give you 1000 formula to remember because whenever I create a formula, I try to create a general formula. And the task for you will not be just to remember the formula, it will be also to remember the case where that formula is applicable, and that becomes a very tedious task. So I only give you a shortcut when I see that the shortcut or this formula holds relevance in at least some of the cases. If it does not hold this relevance, I will not give you any such formula. So I'll not tell you how this is done, how they have done it here. Now what I'll do is I'll hope, and hope is a good thing to have. I'll give you this question, and I hope that you can solve this. Let's see if you can do this. I will just get it on screen. Yes, it's on the screen now. A similar question. Three identical rods of length 1 meter each. The length is same. Having cross-section area of 1 centimeter square. Cross-section area is also same. And made up of aluminum, copper, and steel, respectively, are maintained at temperature 12, 4, and 50 degrees, respectively, at their separate ends. Find the temperature of the common junction. Remember, now you cannot do it by a series parallel. Do we understand this? Because they are not in series parallel. Do you understand this?
Yes, sir. Yes, sir.
The baton passes on to you, my dear friends. Let's see. What do you come up with? Remember, you can assume any random direction of current. It is same for heat current as well as for electric current. The only thing is when you assume that direction and you get your answer as negative, your direction was ulta. You just make it ulta. Ulta, sida, sida, ulta. Your time starts now. Any hope? Well, this question consists of
Doing, sir.
some calculations, so I'll give you that much. I'll give you the calculation time. I'll wait for 1 more minute. Remember, I'm waiting for an answer.
Just 30 seconds.
30 seconds is what has been asked. Okay, I'll give you 30 seconds. The solution is right there on board. I'll give you 30 seconds. I'll just give you 30 seconds. I'll take it out. Okay. Anyone with an answer? Okay, I'll tell you. No, not a complicated problem. The answer, whatever it is. Now, the way that this question is done here in this sheet that I have shared is the same way that I had done the previous question, but it is done in a different way, and I'm going to do it in the same way because whatever I'm going to tell you after this will depend on how good you understand this. Just elaborated, I've just increased. So, as you can see, this gentleman is my common junction. Do you understand this common junction? Which has a temperature T. Do we understand this? Can you see me? Yes or no?
Yes, sir.
Okay. Now, what I have done in the previous question, I had done that one current is coming like this in this rod, then it is going like this. I could easily do that, not a problem. But instead of doing it this way, what I can also do is I can assume that one heat current is going like this, one heat current is going like this, and the other heat current is going. So all three of them are going outward. I can assume that I know that all three of them cannot be outward. One of them has to be inward, but I can always assume that they are all outward. If one is inward, the answer would be negative. Yes or no? Yes or no?
Yes, sir. Yes.
Let me call this as I aluminum. Let me call this as I steel. And let me call this as I copper. So I have a very simple equation that I aluminum plus I steel plus I copper would be equal to 0. Yes or no?
Yes, sir.
Now, since I have taken them all outside,
Sir, 12.17 degrees Celsius.
okay, let us see. I aluminum will be T minus 12 divided by resistance of aluminum. Yes or no?
Yes, sir.
I steel will be T minus 51 divided by resistance of steel. Yes or no?
Sir.
I copper will be T minus 4 divided by resistance of copper. Yes or no?
Yes.
You just need to find out that resistance. Resistance of anything will be L by K. You can put the values and get the answer finally. Do we understand this?
Yes, sir.
What is the final answer coming, my dear bacha? What is the final answer coming? Do we have the final answer, anyone? And the final answer, I think, is 10 degrees Celsius. That is the final answer. If you got anything else, if you did it in the same way, you might not have taken them all out. You might have taken one in and the other two out. Doesn't make any difference. The answer will still remain same. The only thing is, your direction may be correct. My one direction is definitely wrong. At least one. It can happen that all my directions are wrong. Doesn't matter. Once the value of T is found out, I can very easily find out the currents and the direction of all the currents here. Do we understand this, bacha?
Yes, sir.
Anyone understand this, how it is done? Can I have some raise hand that we understand this? Yes or no?
Yes, sir.
Okay, then you have this sheet with you, and there are a couple of questions that I want you to do it. For example, this example number 3, I am giving this example as an homework. Find it out in your sheet. You have already got this sheet, yes or no?
Yes, sir.
So this example number 3 is a homework exercise that you will have to do. Then this example number 5, you can also do example number 4, but example number 5 is again a homework question. Does this diagram remind you of something? Does this diagram remind you of something? Steel, copper, copper, steel, copper. Does it remind you of anything?
Yes, sir.
What?
Um,
What? No? Okay.
Wheatstone
Solve
Bridge.
the question. Yes.
It's like Wheatstone Bridge.
Yes, it's not like Wheatstone Bridge. It is a balanced Wheatstone Bridge, bacha. It is a balanced Wheatstone Bridge. No doubts about this. Then you will have to go through this question. You don't have to solve it. You just need to remember this. Can you do that for me? The value of the thermal resistance, you have to remember this. You will not be getting time to solve this. And the value of current. Can you do that for me? Draw
Okay,
this
sir.
diagram and write this formula. Yes or no?
Yes, sir.
That is what I'm expecting you to do this before you come for the next class. Remember, you cannot miss a class. If you are breathing, you must be. Even if you are in a coma, you must, the monitor in front of your eyes, even if you are in coma, must be of the class that is happening. Because when you get out of coma, you have to get into an IIT, right? So you cannot give an excuse, sir, I was in coma, so I could not prepare for an IIT. Even in coma, have that screen in front of you that you are watching it. Is it okay? Is it clear to everyone?
Yes, sir.
Okay, then we will meet in the next class with all this preparation. If you have missed it by any chance, whatever I've said sarcastically. If you missed any class for whatever reasons, please go through the previous lectures. Okay. So then I'll meet in the next class. I hope you enjoyed it, and we will wind up conduction with some JEE problems, more JEE problems in the next class. We'll wind up conduction in the next class. Take care and have a nice day, bacha. Bye bye.